All right, so we're going to review the homework from the week. We'll start with entry 1 here. I'm just going to abbreviate things. So remember that solutions are the two homogeneous mixtures. This is from entry 1. So your two solutions, these are the ones that are evenly mixed. Think like Kool-Aid is one. That will be a solution because the Kool-Aid powder dissolves, which means I'm just going to put HO here for homogeneous. And the other one, this was an example from the notes, was salt water. Again, the salt dissolves completely. Okay, so that one is also homogeneous. That means that the other ones are my colloids and suspensions, which are heterogeneous mixtures or unevenly mixed. Unevenly mixed. Okay. So now, remember suspensions, those are the ones where particles will settle out over time. So think about if you had like a rug and you smacked it out, and dust went into there, eventually that dust would settle down to the ground. And that means it's a suspension. Okay, the other one like that would be sand and water. The sand would sink to the bottom. Both of those are completely sus. Nice sus joke there for you. And milk and shaving cream then, these are two examples mentioned in the video lectures. Those are colloids. Okay, next, you're supposed to draw what the molecules look like in the solid, the Hale or the plasma. So remember, in the solid, the particles should all be touching. Okay, I don't have to draw like a ton. I'm going to draw like 9 of them. They should all be touching. Okay, and then at a baseline, and then I should show that they're vibrating in place. Right, those little like quotation marks, they are vibrating in place. Okay. And I could even go so far to make a key and make this as a water molecule. And if I know exactly what type of molecule it is, it should be water molecule. Okay. Now plasmas, remember, they have particles that are spread apart. You got your big ones. Okay, some of these are positively charged. I'm going to do one more, just so it's pretty clear. Some of these are positively charged, some of these are negatively charged, some of them are neutral. And then remember, I'm going to have some smaller, I'm going to color them in, smaller electrons as well in there. Okay, now remember, a plasma is an ionized gas, so they are moving in straight lines, kind of in random directions. They are moving in straight lines in kind of random directions. Okay, so you should be displaying the movement of all those as well. This is your plasma. Remember the little ones. These are just going to be electrons. I'm going to say E negative. And then these big ones, these are just going to say, I'm going to say air molecules or particles. Some of them are positively or negatively charged. Ions. So you could do that as well. Positive or negative. These are your ionized air molecules, ions. Okay. So that's day 1. Let's go to our second presentation. Where are we going here? I want to discard those annotations. Let's go to our other one. A slideshow, play from current slide. Okay, so we already went over the first one. So atomic number 52, when I look at my periodic table, that's Te, that's beryllium. 36 is krypton. Sorry, my light's off in my classroom. I'm trying to look at the big periodic table. Si is silicon, that is number 14. 17 is chlorine, that's Cl. And 48 is cadmium, that is Cd. Okay, period. And remember, potassium's 19. Okay, so period is row, so potassium is row 4. Te is row 2, 3, 4, 5. Krypton is row 1, 2, 3, 4, 5 as well. And silicon is row 3. Yep, great. Chlorine is also row 3. And cadmium is row 5 as well. Group then is column. Okay, so potassium's in column 1. Te is in column 16. Krypton is in column 18. That's my noble gases. Silicon is a metalloid. It's in column 14. Chlorine is 17. That's a halogen. And cadmium is a transition metal. That is in column 12. Okay, so I'm going to say cadmium is a metal. Chlorine is a nonmetal. Silicon is a metalloid. I'm going to say Ml as an abbreviation. Krypton is a nonmetal, specifically a noble gas. Beryllium is a metalloid. Okay, and potassium is a metal. Okay, protons, 19, 52, same as atomic number, 36, 14, 17, and 48. And that will be the same for your electrons as well. Okay, so all these are going to slide over one box. Neutrons I need to subtract. Okay, so that means I need atomic masses. So this is 39.09 is the atomic mass from the periodic table. Te, oh boy, it's going to be difficult to see. 127. Okay, 127. Oh, I have a periodic table right here. Give me 1 second. There we go. Te 127.6. It's a terrible 127. Krypton is 83.8. And silicon is 28.09. Chlorine is 35.45. And cadmium is 112.41. I'm going to find a better way to do answers here in the future. So here I got to round this to the nearest whole. That would be 39 minus 19 gives me 20 neutrons. Round this to the nearest whole, that's 128. Minus 52 gives me 76 neutrons. Round this to the nearest whole, that's 84. Minus 36 would be 48. Silicon is 28 minus 14, that gives me 14. 35 minus 17 gives me 18. And nearest whole over here is 112 minus 48 is 12 plus 2, that's 14, 62. 62. Okay. Let's go to our last one. So here, protons, I have to find iron. Iron has 26 protons. Okay. And oxygen has 8. Okay. Electrons is the same, except here I lost 3. So that gives me 23. Oxygen is 8, except it gains 2. Remember, electrons are negatively charged. You got to do the opposite, so that's 10. Now I have to look at the periodic table. Iron's mass is 55.85, so that's 56. Minus 26 gives me 30 neutrons. Oxygen's mass is 16. Minus 8 gives me, 8 neutrons. Okay. And then lastly, we have ions here. So this is a +2. So let's do that. This is calcium, which it loses 2. Vanadium lost 5. Phosphorus gained 3. Fluorine gained, I want to undo that. It gained 1. So those are G's and L's. Okay, so that's gonna go back to everything else. So calcium's atomic number is number 20. So it has 20 protons, and its mass is 40.08. 40.08. Vanadium is atomic number 23, so 23 protons. Its mass is 50.94. Okay. Phosphorus, the atomic mass is 30.97. Its atomic number is 15, if my memory serves me right. Yep, 15. And fluorine is atomic number 9, so 9 protons, mass of 19.00. Different periodic tables might be slightly different in their numbers. So electrons, normally I'd have 20, but I lost 2, so I have 18. Electrons, normally 23, but I lost 5, 18. Okay, phosphorus, normally I have 15, but I gain 3, that gives me 18. Okay. And fluorine has 9, but I gain 1, so that gives me 10. Okay, now, notice that this is 18, 18, 18. All those end up with the same number of electrons. So let's go look at our periodic table really quick and notice where they're at. Okay. If I was thinking, I would have put a, there it is. Okay, so notice, calcium is right here. It loses 2 electrons, 1, 2, to become like argon. It becomes like a noble gas by losing 2 electrons, 20, 19 to 18. That's great. Vanadium loses 1, 2, 3, 4, 5 to be like argon, number 18. Okay. Phosphorus gains 1, 2, 3 to become like argon. And fluorine gains 1 to become like neon. So what you're noticing about these gaining and losing electrons, hopefully, as I'm saying this, is that they do it to become like these noble gases. So there's something about those noble gases that every other element wants to be like. It's called the noble gas configuration, and we'll talk more about that later. Okay, but just notice that the numbers that they get to, oxygen's 10, just like fluorine, and like iron's a slightly different case. So we'll talk about that when we get there. That has to do with electron configuration. All right, so now 40 minus 20 gives me 20 neutrons. Remember, round to the nearest whole, then subtract. 51 minus 23 gives me 28. And 31 minus 18 gives me 13. Neutrons, 19 minus 9. Oh, wait. 31 minus 15 gives me 16. 51 minus 23 gives me 28. That's my fault. 31 minus 15 is 16. 19 minus 9 gives me 10. Period is row. This is row 2, group 17. And which one is this? This is phosphorus. This is row 3 or period 3, group 15. We have iron, which is in row 4, number 1, 2, 3, 4, 5, 6, 7, 8, group 8. Okay. And lastly, I have calcium, which is in row 4, column 2, period and group. Remember, everything in the same group have the same properties or very similar properties. So all these have different properties, even if they're somewhat similar. Okay, let me know if you have questions. That's the week's homework. You should try the review stuff that I posted as well.